except where otherwise noted. Data are given for materials in their standard state. Harmine, also known as telepathine, is a fluorescent harmal or alkaloid belonging to the beta-carboline family of compounds. It occurs in a number of different plants, most notably the Middle Eastern plant harmal or Syrian and the South American vine Banisteriopsis caapi. Harmine reversibly inhibits monoamine oxidase, an enzyme which breaks down monoamines, making it a RIMA. Harmine selectively binds to MAO-A, but does not inhibit the variant MAO-B. Isolated from the plant Peganum Harmala, harmine is an indole alkaloid with the pyridoindole ring structure that is characteristic of the I-circumflex superscript 2 carboline alkaloids. The I-circumflex superscript 2 carboline alkaloids include as harmine, harmaline, harman and harmalol. These molecules are heterocyclic amines, biosynthesized through the combination of 5 and 6-membered ring structures that are derived from an amino acid, either L-tryptophan or tryptamine, which facilitates the formation of an indole ring system. The coincident occurrence of I-circumflex superscript 2 carboline alkaloids and serotonin in P. harmala indicates the presence of two very similar, interrelated biosynthetic pathways, which makes it difficult to definitively identify whether free tryptamine or L-tryptophan is the precursor to the biosynthesis of harmine. However, it is postulated that L-tryptophan is the most likely precursor, with tryptamine existing as an intermediate in the pathway. The following figure shows the proposed biosynthetic scheme for harmine. The shikimate acid pathway yields the aromatic amino acid, L-tryptophan. Decarboxylation of L-tryptophan by aromatic L-amino acid decarboxylase produces tryptamine, which contains a nucleophilic center at the C2 carbon of the indole ring due to the adjacent nitrogen atom that enables the participation in a managed type reaction. Rearrangements enable the formation of a shift base from tryptamine, which then reacts with pyruvate to form a I-circumflex superscript 2 carboline carboxylic acid. The I-circumflex superscript 2 carboline carboxylic acid subsequently undergoes decarboxylation to produce 1-methyl I-circumflex superscript 2 carboline 3. Hydroxylation followed by methylation in IV yields harmaline. The order of methylation and hydroxylation have been shown to be inconsequential to the formation of the harmaline intermediate. In the last step V, the oxidation of harmaline is accompanied by the loss of water and effectively generates harmine. The difficulty distinguishing between L-tryptophan and free tryptamine as the precursor of harmine biosynthesis originates from the presence of the serotonin biosynthetic pathway, which closely resembles that of harmine, yet necessitates the availability of free tryptamine as its precursor. As such, it is unclear if the decarboxylation of L-tryptophan or the incorporation of pyruvate into the basic tryptamine structure is the first step of harmine biosynthesis. However, feeding experiments involving the feeding of one of tryptamine to hairy root cultures of P. harmala showed that the feeding of tryptamine yielded a great increase in serotonin levels with little to no effect on I-circumflex superscript 2 carboline levels, confirming that tryptamine is the precursor for serotonin, and indicating that it is likely only an intermediate in the biosynthesis of harmine. Otherwise comparable increases in harmine levels would have been observed. Monoamines include neurotransmitters, hormones and psychedelic drugs. By slowing the breakdown of neurotransmitters, monoamine oxidase inhibitors can help to replenish the body's supply of these chemicals, and many MAO-As are used as antidepressants. Harmine has not been the subject of much clinical research in the treatment of depression, which could be due in part to its restricted legal status in many countries, as well as the existence of synthetic MAO-As with fewer side effects. P. harmala and B-caapi are both traditionally used for their psychoactive effects. B-caapi has a tradition of use in conjunction with plants containing the drug DMT. Traditionally, B-caapi is consumed as a drink, with or without the DMT-bearing plants. Ordinarily, DMT is not active when taken orally, but users report very different effects when MAO-As are present in such beverages. Harmine and substances containing it have been used in conjunction with many other drugs by modern experimenters. Many hallucinogens appear to exhibit increased potency when used in this way,